Imagine, if you will, a place where time and space become one, where the laws of physics as we know them cease to exist. This, my friends, is not the premise of a science fiction novel. No, we are venturing into the realm of the real, the mysterious, and the infinitely fascinating world of dark holes. Now, what is a dark hole, you may ask? Picture this: a region in space where the gravitational force is so incredibly strong that absolutely nothing can escape from its clutches. We're talking about a force so potent, so dominant, that not a single particle, not even the fastest thing in the universe, light, can escape from it. To better understand this, envision a whirlpool. You've seen how water gets sucked into its vortex, right? Imagine that, but on an incomprehensibly massive scale. A whirlpool in this comparison devours water, while a dark hole devours everything: matter, energy, light, you name it. It's as if the dark hole is the universe's most voracious predator, continually feasting and never satiated. But why dark hole? Well, since light can't escape from it, it appears utterly dark, hence the name. It's like a cosmic shadow, an astronomical phantom lurking in the depths of the universe. So what do we know about these dark holes? Well, they're not visible through conventional telescopes. They are detected through their immense gravitational effects on their surroundings. They distort the fabric of space-time itself, leading to a phenomenon known as gravitational lensing. This is where light from a distant star, passing close to a dark hole, is bent and magnified, creating a unique and often beautiful cosmic spectacle. So in essence, a dark hole is an astronomical enigma, a point in space where matter is so dense that it creates a gravitational pull from which even light cannot escape. It's a testament to the universe's unending capacity for wonder and mystery, a reminder that there's so much more out there for us to explore and understand. But how do these astronomical phenomena, these dark holes, come into existence? This question has intrigued scientists and stargazers for centuries. The formation of dark holes is a cosmic drama that unfolds at the end of a star's lifetime, a grand event that astrophysicists often term as a supernova. Imagine a star, massive and radiant, dominating its corner of the universe. It's a juggernaut of nuclear fusion, constantly converting hydrogen into helium, radiating energy as light and heat. This ongoing fusion reaction creates a tremendous outward push, constantly battling the inward pull of the star's own gravity. A delicate balance is maintained, keeping the star stable. However, as the star ages, its fuel slowly depletes. There comes a point when the hydrogen runs out, and the star begins fusing heavier elements like carbon and oxygen. Each successive stage of fusion happens faster and faster, and the star swells into a red giant. Eventually, the star starts fusing iron, which is the end of the road. Iron fusion doesn't produce energy like the previous stages. Instead, it consumes energy, destabilizing the star. With nothing left to fuse and no outward pressure to counteract gravity, the star's core collapses under its own weight. This implosion happens so fast and with such force that it causes a massive explosion, a supernova. The outer layers of the star are blown away, leaving behind only the core. Now, if this core is more than about 3 times the mass of our Sun, it will collapse further into a point of infinite density, a singularity. The gravity around this singularity is so intense that nothing, not even light, can escape its pull. This is the birth of a dark hole. Despite their ominous name, dark holes are fascinating objects. They are the ultimate proof of Einstein's theory of relativity, demonstrating how mass can warp space and time. They are the universe's ultimate recycling centers, breaking down matter and energy and spewing them out in different forms. And so, from the ashes of a dying star, a dark hole is born, forever altering the fabric of space-time. What lies within these celestial devourers, you may wonder? Enveloped in an air of mystery and intrigue, dark holes are more than just cosmic anomalies. They're fascinating structures, each component playing a significant role in their enigmatic behavior. To help understand these cosmic giants, let's break down their anatomy into 2 main parts: the event horizon and the singularity. Imagine a deep well, one you can't see the bottom of. This is akin to the event horizon, the boundary of the dark hole. It's the point of no return, where the gravitational pull becomes so strong that nothing, not even light, can escape it. Picture yourself standing at the edge of this well. If you were to toss a stone in, it would disappear, swallowed by the darkness. The same occurs at the event horizon of a dark hole. Any matter or energy that crosses this threshold is consumed, never to return. Now let's delve deeper into the dark hole, beyond the event horizon, to a place called the singularity. Think of the singularity as a bottomless pit, a point of infinite density where our understanding of physics and the laws of the universe break down. Here, all the matter that the dark hole has swallowed is crushed into an infinite point of density. The singularity is the heart of the dark hole, the engine that powers its insatiable appetite. It's important to note that while we've used analogies to simplify these concepts, the reality of dark holes is far more complex and intriguing. They challenge our understanding of the universe, pushing the boundaries of what we know and what we can imagine. So, what lies within these celestial devourers? An intricate structure of unfathomable depth and complexity, an event horizon that marks the boundary of the unthinkable, and a singularity where the laws of the universe as we know them cease to exist. Despite their ominous presence, the structure of dark holes is incredibly fascinating, with each part playing a significant role in their mysterious behavior. Now, one might be curious, what happens when something ventures too close to a dark hole? Well, the answer is both fascinating and a bit terrifying. Dark holes, these voracious cosmic vacuum cleaners, have a profound effect on the surrounding space and matter. Picture a dark hole as a whirlpool in the cosmic sea. Everything that comes too close spirals in, irresistibly drawn by the immense gravitational pull. Light, matter, entire stars. Nothing escapes a dark hole's insatiable appetite. But the influence of a dark hole extends beyond its event horizon. Around a dark hole, the fabric of space and time is not just curved, it's twisted and stretched, like a rubber sheet with a heavy ball placed in the middle. This distortion of space-time is so extreme that it causes what's known as time dilation. Imagine yourself standing on the edge of a dark hole. To you, time would seem to flow normally, but to a distant observer, your watch would appear to slow down. And if you were to fall into the dark hole, they would see you freeze, like a picture on pause, while you'd feel as if you were falling forever. This is the bizarre and counterintuitive world of dark holes. But it's not all doom and gloom. These peculiar effects have been invaluable in testing and confirming Einstein's theory of general relativity. They've also led to mind-bending concepts like wormholes, hypothetical shortcuts through space and time. So, while dark holes are fearsome and destructive, they're also fascinating. They challenge our understanding of the universe and force us to think in ways we never have before. They're reminders of the vast, mysterious cosmos we're a part of, and the countless secrets it holds. It's an intriguing paradox, isn't it? Dark holes, while destructive, contribute to our understanding of the universe and its laws. So, where do dark holes fit in the grand scheme of our universe? The answer to this question is as complex and intriguing as the dark holes themselves. Dark holes, these swirling vortexes of nothingness, play an unexpectedly pivotal role in the grandeur of our universe. They are not merely the devourers of light and matter, but also the architects and sculptors of galaxies. Imagine dark holes as the seeds of a galaxy. When a dark hole forms, it begins to attract matter and gas from its surroundings, forming an accretion disk around itself. This disk gradually condenses and forms stars, and these stars eventually arrange themselves into galaxies. In this way, dark holes serve as the cradle for the birth of galaxies, nurturing them into existence. But their influence extends even further. Dark holes, with their immense gravitational pull, can influence the movement and paths of celestial bodies. Stars, planets, even entire galaxies can have their trajectories altered by the gravity of a dark hole. They are the unseen puppeteers, pulling the strings of celestial objects and guiding their cosmic dance. And what if I told you that dark holes might even be gateways to new universes? Some theories propose that the matter sucked in by a dark hole doesn't just disappear, but could potentially be expelled in a white hole in a different universe, thus possibly giving birth to new universes. It's a mind-bending concept, and while it's still a theory, it highlights the unimaginable potential and influence of dark holes. So you see, dark holes are not just cosmic monsters swallowing everything in their path. They are creators, influencers, and maybe even universe builders. They are an essential part of the complex machinery of our universe, the silent gears turning in the background, influencing the cosmos in ways we can't even begin to fathom. In the cosmic dance of the universe, dark holes are the enigmatic performers, shaping and influencing the world around them in ways we are still striving to understand.